This is a lecture for reviewing the exercise 8, the cognitive management exercise. We begin with problem 4. The problem 4 and problem 5 talk about the process capability. Both of them ask you to obtain the CPK. So how to obtain the CPK? According to the formula, we need to know, at least we need to have the CP and have a K, or we want to choose a minimum number for the upper limit or the lower limit. So in the PowerPoint, I provided you two ways to obtain the CPK. So take a look at the problem 4. Here are the information we obtain: the target value, the average value, the upper specification limits, the lower specification limits, and the standard deviation. So according to the formula, the CPK equals to CP times 1 minus K. So we need to know what is the value of CP, what is the value of K. K equal to the absolute value of the target minus the average. The target is 20, the average, the mean is also 20. And we don't need to consider about this part because we obtain 0 with the numerator is 0, so the K equals to 0. But we still need to understand what this in this part. So if we want to know the values of this part, we need to find what is the upper specification limits and the lower specification limits. So after we obtain the K, which is 0, we need to find the CP. CP equals to the absolute value of the differences between the upper limits and the lower limits, and the S here divided by the 6 standard deviation. So we use 28 minus 12 and we choose the absolute value of it and divided by the 6 times the sigma. Sigma is the standard deviation, which is 5, so we will be able to obtain the CP. And because of CPK equals to CP times 1 minus K, it equals to 0.533 times 1 minus 0. It equals to 0.533. So this is the number for the CPK for problem 4. And for the problem 5, it is very similar to problem 4. It is also asked for a CPK, and we use the similar way to calculate the CP first and the K first, and then compute the K, and then we will be able to obtain the CPK, which equals to the CP times 1 minus K, and we obtain 1.678 for problem 5. And for the problem 6 and problem 7, they talks about the control chart and they focus on the X-bar chart. So we have two ways to obtain the X-bar chart. The first one, if we know the range for the samples, then we can compute the average of a range. Then we can choose the first way to obtain the upper limits and lower limits and the average, the center line. If we know the standard deviation, the sigma, then we will be able to obtain the sigma x. So we will be able to use the second way to obtain an X-bar chart. And for the problem 6, actually it has a specific requirements for the method you should choose for the control chart, because it asks you to begin with calculating the overall standard deviation and the standard error, which is the sigma x. So which means we need to choose the second method to obtain the X-bar chart. And if we want to obtain the X-bar chart, just like the requirements of problem 6, we need to start with calculate the sigma, the standard deviation first, and then we move to calculate the standard error, which is the sigma x, and then we will be able to obtain the limits, both the upper control and the lower control limits, and you will be able to draw the control charts. So for problem 6 here, the first step for us is to use the formula I provide to you to compute the standard deviation, the sigma. So sigma equals to the square root of the differentiation between the actual value we connect and the average, the mean. So after calculating by these formulas to obtain the sigma equal to 5.935, or you may obtain a number around this one, depends on the decimals you choose. Some students may obtain the standard deviation with 5.8 something, so it all be right. And after we obtain the sigma here, the standard deviation, we will be able to find the standard errors. So we use the number here divided by the square root of the sample size. The sample size for this problem is 3, because for each samples here we have 3 observations, we have 3 items, so we use 5.935 divided by square root of 3, and then we will be able to obtain the standard errors, which is 3.427. So it depends on the decimals you choose. You may have the very similar number, but not exactly same number, and it is correct. Okay. So after we obtain the standard deviation and the standard errors, we will be able to obtain the upper and the lower limits while the formulas here. So the upper limits equal to the average of sample average plus z times the standard errors, and the lower limits equals to the average of the sample average minus z times sigma x bar, the standard errors. So we already know this number, the standard errors is 3.427, and we need to calculate the average of the sample average. The average of sample average asks us to calculate the overall average for all the items we pick. We have 2 ways. The first way is like we calculate the average for each samples, and then we calculate the average of sample average. So we use 59 plus 45 plus 51. We sum all of the 3 numbers together and divide it by 3 to obtain the average for sample 1, which is 51.67. And we can use the same way to obtain all the average here. The average for sample 2 should be 47.67, and for sample 3 is 43.33, and this is the number for the sample for the average number. You can choose 2 decimals, you can choose 3 decimals, you can choose 4 decimals. If you want to get more accurate, like if the numbers, you can have a longer decimals here. So we have 49.33 for the sample 5, and 50 for the sample 6, 48.67, and 49 is for the sample 9. I'm sorry. and the 50 for sample 10. So we just calculate all the average for all the samples over there, and we sum all the average together and to obtain the average of sample average. So we just sum all the numbers here together and divide it by 10 because we have 10 samples in total, and thus we obtain the average x double bar, the average of sample average is equals to 49.5. And z here we choose 3 because this is under a 3 sigma limits. So the upper control limits equals to 49.5 plus 3 times 3.427. It should be 59,779. And for the lower control limits, it equals to 49.5 minus the z, which is 3, times 3.427. It equal to 39.220. So this is about the how to obtain the upper limits and the lower limits. And what if the following questions for problem 6? If you continue connect the data and you have the following 5 samples, and you pick up the atoms for each sample and you obtain the numbers over there. So according to what we obtain here, we will be able to draw the orange line, the yellow line, and the silver line. We are able to construct this control chart. But how to obtain, how to put the samples, how to put the 5 samples into the control chart to evaluate the process is in control or not, then you need to find the point here which represents the sample 1 until the sample 5. So what kinds of values, what kinds of points we should put in this control chart? It depends on the average for each samples you connect here. So for the sample 1, it equals the average for these 3 numbers. So we obtain 51.67. So 51.67 is something we use to represent the sample 1, and the same we can calculate the average for sample 2, and for the sample 3, and for the sample 4, and for the sample 5. Then you just put all the samples into the control chart you obtain. Like for example, the orange line represents the upper control limits. What we obtain here is 59, and you just put those numbers to the control chart to represent the samples. And according to the control chart we obtain here, we find like all of the samples, all of the 5 samples within the limits, and they just across to the center line. So we think this is in control for the problem 6. And the same for the problem 7, because it doesn't ask you to compute the standard deviation first and then move to the standard errors and then move to the limits. So you can choose another way. You can choose to compute the range first and compute the average and use these formulas to obtain the limits. So if we choose the second method for problem 7, the first thing is like we need to calculate the range. So how to calculate the range? The range equals to the largest number minus the smallest number in a sample. So for the sample 1, the largest number So I changed the table because the table I used before is like for the problem 6, not for the problem 7. So I upload the correct tables over there. So for the range, we need to use the largest number minus the smallest number, right? For the sample 1, the largest number is 101 minus the smallest number, which is 98. Then we obtain 3. And we can use the same way to calculate the range for the following 9 samples. So for sample 2, we have 89. And we have 9 for sample 3, 3 for sample 4, 2 for sample 5, 6 for sample 6, 4 for sample 7, 2 for sample 8, 7 for sample 9, and 3 for sample 10. So this is all the ranges. Then we could able to calculate the average range. We just sum all of the numbers we obtain for range for each sample, and we obtain the average range, which is 12.8. And the 12.8 is what we use ABA to represent. So if we want to know the limits, at least we already obtain the average of a range. And the A2 is the constant we can obtain for the table, which provided in the textbook and the slides according to the sample size. And another value we need to compute for the upper and lower limits for the X bar chart is the average. Is still of the average of sample average. So we use the same way to calculate the average of sample average, and we found it equals to 97.725. So this is the average of sample average, and according to the table we will be able to know the value of A2 because the sample size is 4. You should be very careful about the sample size and the number of samples. The sample size is the items in the number of the items in each sample. So in each sample we have 4 items. So the sample size is 4. If sample size is 4, then the A2 will be 0.729. So for the upper control limits, it equals to x double bar plus A2 times the average of range, which is the 97.725 plus A2, which is 0.729. We obtain for this table times the average range. The average range is 12.8. So we obtain the upper limits is 107.056. And we use the similar way to calculate the lower control limits. So it equals to the x double bar minus A2 times the average of range, and we obtain 88.394 as the lower control limits. So according to those upper limits and the lower control limits and the center line, the value for the average of sample average, we will be able to draw these 3 lines. And similar, if the problem provided you the following 5 samples and with the data they collect. So if we want to know the process is still in control or out of control, we just need to put the average number. Here is the 98.5, 99.5 for sample 2, 98 for sample 3, 104.5 for sample 4, and 100.5 for sample 5. You just need to plot those numbers into the control chart you obtain, and you will be able to know to take a look at these figures to have the conclusion whether it is in control or out of control. According the figures we obtain here, we see that it is in control. So this is how we use the second method to obtain the X-bar chart and to analyze whether the process is in control or out of control. So this is all the review for the exercise 8.